This is DSE practice paper, paper 1, question 19. In part A, please read the question carefully. It is about the investment of a commercial firm. And the first year, the amount is $4 million, and it is 8% less than the previous year. And we also know that the total amount in the fourth year is $104,576. So how can we use this to find out in part A is that we can set up an equation, and 4 million times 1 minus 8% to power 3. Here 3 comes from the difference between the fourth and the first year, and it will be equal to 104,576 from the question. Then we can solve for the R. 1 minus 8% to power 3 will be the fraction written there. And then by using the calculator, that 0.64 is the cubic root of the right hand side. So R is equal to 36. This is part A. Then for part B, it is about another amount revenue. And the revenue in the first year is $2 million, and it is 20% less than the previous year in each year. So how can we find out the B1, that this number of year needed for the total revenue to be to exceed $9 million? So we need to let n be the number of year needed. Then we can set up an inequality. The left-hand side will be the sum of the revenue in the first n years, and we need to calculate the sum to make it greater than 9 million. So at the left-hand side, we can apply the sum of GS. The first term is 2 million, and the common ratio is 0.8. It comes from 1 minus 20%, and the number of term is the number of year, which is n. So by using the formula, we can have the left-hand side greater than 9 million using the formula. Then we can have 1 minus 0.8 to power n is greater than 0.9 by using the calculator. So 0.8 to power n is less than 0.1. Then how can we solve for n here? Because n is in the index, so the common way for us to solve this kind of problem is to take the logarithm. So n times log 0.8 will be less than and log 0.1. So moving the 0.8 and log 0.8 to the right hand side, I can get another inequality. Now, however, please be careful about this one. The inequality is changing from less than to greater than. The reason is that log 0.8 is a negative number. So when I divide both sides by a negative number, we need to change the sign of the inequality. So we have n greater than 10.3188516. So the answer for part B1, that is number of year we need, is 11. Okay, it is the smallest integer greater than 10.31 something. So this is B1. Part B2, we need to determine will the total revenue exceed $10 million. Now we can use the result of B1. I mean, there's some calculation in B1. The total revenue in the first n years is given by 2 million plus the 2 million times 1 minus 20% and so on. This is that one we calculate in B1, and by using some of GS, then we can have this formula. Okay, again same as B1. Then after we simplify, then we can get 10 million times 1 minus 0.8 to power n, and this is the total revenue in the first n years. And you can see that no matter what is the n, 1 minus 0.8 to power n will be less than 1. Okay, it can be about 1 minus a very small number. Then the total number will be less than 10 million dollars. So no matter what is the end, the total revenue is less than $10 million. So as a conclusion, we have the total revenue will not exceed $10 million. So this is part B2. Okay, B3. This is about to the question to compare the total revenue and the total investment. So from the result part one, we know that with the value of R, and also we can find out the total amount of the investment, and the total amount of investment in the first K years is given by this, and by using the sum of GS, it will be given by 4 million times 1 minus 0.64 to the power K over 1 minus 0.64. Okay, R is 36 in part A, so 1 minus R percent is 0.64. And for first K years, so this is the sum of the total investment. Second, let's find and after we simplify, then we can get the 100 million over 9 times 1 minus 0.6412K. Okay. Next is about the total revenue in the first K years, which we found in part B. So in the question, when we need to compare whether the total revenue exceeds the total amount of the investment. Okay, the total revenue is in that one is the expression in green, and the total investment is the amount is the expression in red. So we need to do the calculation, do the subtraction between these two. The total revenue minus the total investment in the first K years, then will be given by the difference of the green expression minus the red expression. And please be careful about the zeros there. In the total revenue, there are 10 millions times the bracket. But in the total investment, it is 100 million over 9 times the bracket. So with the common denominator, we have 90 million times 1 minus 0.8 to the power k minus the numerator in the investment. Then the next step is to take out the common factor, 10 million, yes, 10 million over 9. And then with 9 times 1 minus 0.8 to the power k minus 10 times 1 minus 0.64 to the power k. Then when I expand the expression in the square bracket, I can have the second step here, and also just group the terms. Then we can have in the square bracket 10 times 0.64 to the power k minus 9 times 0.8 to the power k, and then minus 1. Okay, the 10 million over 9 is the same in every steps. So let's look at that terms in the square bracket. Here with 0.8 to the power k and 0.64 to the power k, and you should observe the relationship between these two. And you know that 0.8 to the power 2 will be 0.64. So we can have the following step to write 0.64 to the power k as 0.8 to the power k and then square. Then you can see that after I express in this form, then it will be a quadratic expression in 0.8 to the power k. Then to find out whether it is positive or negative, because we have the subtraction there, we need to factorize. And now you can use a calculator, and you may find out, or we can factorize to become two terms. But if the calculator shows that there is math error, then it means that you cannot factorize. Then most likely, then we should use the complex square. But now we can factorize into two expressions. And we can now compare the sign of these two expressions. Now, how can we compare is that for the first one, because k is a positive integer, so the first expression must be positive because everything in the first bracket is are all positive. And for the expression in the second bracket, it will be negative because 0.8 to the power k will be a decimal number less than 1 because k is a positive integer. So the expression in the second bracket will be less than 0. So combine these two results, we can have uh, uh, the total revenue minus the total investment will be less than 0. So it means that for any k, the total revenue will not exceed the total investment. Okay, for any no matter what is the k here. So the claim is disagrees. So this is the result of part C.